Hi, in this video I'm going to show you the workflow from 3D scan to CAD using the new Creality Scan 4 version 1.2.8. Now after you fuse the point cloud, the Creality Scan 4 will produce the mesh instead of the point cloud. You can no longer view the point cloud in this viewport, and after you merge your multiple scans together, you have option to export the mesh in three formats: STL, PLY, and OBJ, same as before. And you can also export the point cloud that you are not be able to see in the viewport, but you can export it. And I will show you that this version of the software, the point cloud and the mesh, it has no discrepancy, give exactly the same precision, accuracy, and the dimension. You can now use the mesh from the Creality Scan 4 for doing the reverse engineering without sacrificing the precision and accuracy. Okay, for this demonstration, I will make a 3D scan of this fishing lure. This one was sent to me by a customer from California. He wants me to design a split mold for casting. So here's a split mold that I made. To be able to cut the negative mold, I need to reverse the rule, and in this video I'm going to demonstrate using point cloud and the mesh, because it's going to be a different approach for Autodesk Inventor. This rule is not difficult to reverse on the body part. I can loft it like 3 times to complete this, and it's symmetry on both left and right, but the gills is quite difficult to reverse because the gill is an organic shape. I may need to slice with a thin section about 3 millimeters, do a multiple slice and gradually change the shape so that it can form the grill shape here. So I need to clearly see the edges of the grill. So I need to use a laser scanner to scan this part. You can either use the adapter 7 lines laser, but in this video I'll use the S1. Okay, first I'm going to do a global marker scanning of this turntable. Because this table is made with PLA plastic, if it's made from glass or metal, then you wouldn't have to redo the global marker, because the moisture and temperature change can deform the turntable. Marker that you put on is going to move. It doesn't take a long time for scanning the global marker. Export it, place the clay here. It's best to scan the object parallel to the turntable. So I'm going to choose 0.15 for the resolution, and I'll use parallel lines. Fifth to the second side here. "90 frames per second. For the S1, I can finish the job faster. I'm going to make a third scan. This will be a bridge scan. So this scan will contain information on both sides. If it has a 3 scan, it can merge automatically. Let's fuse all the scanned. 0.15. Use the blue laser. It will fuse much quicker than the infrared. You should fuse it before you start cleaning up, because what you have deleted may come back and you may lose some of the scan data. This third scan is the bridge scan. It contains both sides of the surface, so there's a lot of overlap area, so you can align them automatically. So you don't have to do the manual. alignment, I think it's faster. The third scan, so after merging, you can simply delete it. Okay, I mesh it. Now we have like 870,000 triangle. That would be the maximum output, 0.9. When you mesh it, you should put this number close to this number, so you will not lose the detail. Okay, here's a result from the mesh. I can either export this as the mesh or the point cloud. Most of the time I will use the OBJ format because it works well with the Blender and other software like Adobe Substance 3D Modeler, and it also very compatible with the Autodesk Inventor. If I open the OBJ files in the Autodesk Inventor, I can open it up to more than 20 million faces, and it still runs smoothly in the viewport. And I will also export this as the point cloud. If you want to export as the point cloud, you need to choose here ASC format. You can even open this ASC file with the notepad, and you will see the point coordinate. Okay, so we have the mesh and the point cloud. You can see that the file size is different. OBJ file is larger, 36 megabyte, while the point cloud is smaller, 18 megabyte. Okay, this is cloud compare. I just drag and drop. For the point cloud, we have 348, half the number of the triangle that we export. Okay, this is the mesh. Position of the mesh and the point cloud is exactly the same. If I look from the outside, it's matched. So I will click on both the point cloud and the mesh so that I can align it together. Next, I'm going to slice it. The mesh and the point cloud is aligned. See, if I reduce the size of the point cloud, you may not be able to see it. Let me increase it. So it's aligned, and the wall thickness is very thin for the smoothness one. Okay, next I'm going to move both of the point cloud and the mesh to the origin point, which is duration. Move bounding box to the origin. Now both the mesh and the point cloud is in the 0, 0 point. Okay, now it's all done. Next I will export this point cloud as the LAS file, because I need to convert this LAS file into RCP files. Sound like a complication, and this RCP file will be recognizable by the Autodesk Inventor. Okay, this is Autodesk recap for the mesh file. You don't have to do anything. You can just drop it into Autodesk Inventor and it will just show up. But for the point cloud, you need to convert it using Autodesk Recap, another software that used for converting the point cloud into the recognizable format. So what I have to do is just drop the files, the LS files. It won't recognize the ASC format, so I need to drop in as an LS format. And click here, click one more time, another click here, and the fish will show up. And this will be scaled to meter, because recap is designed for using with the construction project. It will show the correct scale when I import the scan data from the LiDAR scanner that used in the construction. But for the desktop scanner like this, it's going to scale 1000 times larger. So it doesn't matter, I can scale it back in the Autodesk Inventor. Okay, this is the Autodesk Inventor, and I'm in the assembly environment. I have one assembly already opened. You can have many parts in one assembly. So I'm not going to make a tutorial for Autodesk Inventor. I'm going to show you how I reverse it because it's going to be different between the mesh and the point cloud. Let's start with the point cloud. Click on Manage, Attach. I click on the file that I export from the recap, this one, RCP files, and click on Open. It's scaled in meter, so I need to scale it back to millimeter. I need to use a 0.001, so it's 1000 times scale back to millimeter. Click on Insert at Origin, click on OK. So now the lure is here. You can see that the lure should be in the center because we have already aligned it. See here, it's quite center. Okay, to reverse with the point cloud, you need to start by create a new component and select the plane, which is I will choose the XY plane here. So now we have a new part and a new sketch to start with. So I need to slice the point cloud into a thin layer, attach a box crop, and I will start by selecting a thin layer of the point cloud. Usually I like to use 1 millimeter for the thickness. Okay, now I have a clean point cloud for tracing. The lure is symmetry, so I will trace only 1/2. So I project the y-axis. If I'm reversing an inorganic shape, it's going to have a straight line and arc, but this one, it has no flat line and a constant radius. So I will use spline to trace it. There's two kinds of spline. The one is with the control vertex, and this one is the interpolation. I'm going to choose the interpolation because it's the fastest. I will start a little bit past from the symmetry axis. So it's quite easy to use the spline to trace the arc like this. So if your point cloud is thin, this one is less than 20 microns. I think it's around 7 or 8 microns. So when you put your mouse on the wall, it's going to be very precise. This fishing lure doesn't require that much of the precision because it's not going to attach to anything. Okay, next I'm going to trim this. I draw it past the center line and then I trim it. And I'm going to draw a line here. Click here. Uncrop. What I like about the point cloud is that it's like an X-ray frame that you can clearly see everything. I'm going to move the plane here. Click on check mark. I'm going to create a new sketch here on this plane, but before that I need to crop the point cloud. I'm going to create a sketch on this plane. I'm going to project the y-axis, and not to be confused, I will turn off the visibility of the first sketch. I'm going to trim it. Draw the closed loop. Okay, next I'm going to create a rail for lofting. Line from this point to this point has to align with this plane. So I'm going to use the 2D sketch for the rail, not a 3D. Project geometry first. Project this 2 point. Next, I need to make more rails, so I will use 3D sketch. I need to include the geometry from the 2D sketch. Now change to yellow color because it included. I'm gonna use the spline, but this time I will use control vertex spline. I click here from this point to this point, and then I'm going to add the vertex. Next, I'm going to compile the loft command. Click on the first sketch, click on the second sketch. So now it's a loft without a rail. You can see that it has a gap here. So you need to force it to align to the rail. Click on here, click on the rail. The first loft is done. I don't want it to make it long, so I'll show you in a quick way for the rest of the part until I finish the mold. Let's move to the mesh. Import the mesh. Please import CAD files. The OBJ is not a CAD file, but this is how you put it in the Autodesk Inventor. Click on the OBJ file. Let me turn on the realistic view. This is the mesh, about 1 million point. My PC is RTX 4090 with a 14900K CPU, so it's very fast and responsive. Even with the mesh, I can open up to 20 million faces and it's still as fast like this. Okay, one thing you can notice that when you import OBJ files, it will create a part here and the mesh is in this part. I will change the texture to transparent so that I can see through, unlike the point cloud. And the part that you are reversing is going to be transparent as well. So you probably need to switch back and forth between the transparent and the solid to check your reverse part. So I need to switch between the G and V key. G is rotate, V is move. Because there is no flat plane. If there is a flat plane, you can build a plane inside the mesh and align it to the XY plane. I will click on creating a sketch XY plane, and then I'm going to project the X-axis. Next, I'm going to hit on F7 on my keyboard. It's going to slice the plane, but you don't see any line that you can trace with. You need to go to the view, shade with edges. The line is in the black color. You need to change the color. Now you can see the cross-section line. Autodesk Inventor will automatically create a cross-section line in the black color. Use the spline as last time. It's quite difficult to see, even though I set this to a transparent color because it contains the edges. But if I choose the realistic view, you can clearly see the sketch inside. So you need to switch between the realistic and shade with the edges. So you need to change the view mode quite often during the model. I'm going to create a new plane to here, the same point, and then I'm going to create a new sketch, and then I'm going to click on F7. It will create a cross section. You need to go to view, turn on the edges, so the black line will be visible now. I'm going to project the X-axis. And remove this line. Okay, the second sketch is done. Let's change the view back to realistic. Okay, next I'm going to create a new sketch on this plane. Okay, to create a 2D sketch for the rail on the edge here. Project geometry. Using a spline. Okay, next I'm going to create a 3D sketch. Before that, I need to include the geometry first so that I can snap it. Placement of the rail is also important. When you are doing a loft command, you need to place it correctly so it will form the shape of the part, especially the grills one. I'm going to show this later. And insert vertex. I'm going to do the loft command. First sketch, second sketch, click on the rail, 1 0 2 3 4 5. Let me change it to the gray color. Say first loft of the row using the mesh as a reference. Okay, one major difference between reversing with mesh and the point cloud. Now it has the same precision when export with the Creality Scan 4. The disadvantage by using the mesh for reverse in the Autodesk Inventor, one is that when you import the mesh, you need to build it inside of the part. This is the part. So if you need to split your part into small pieces, for example, it's too large for your print bed, it will be more complicated because you are building the model inside of the part. If you want to split it, for example, if I want to split this fishing rod into 2 parts, I need to use the split command and rebuild it again, and then I need to export the splitted part into an assembly, which is quite complicated. For example, if you want to create a dovetail, it will be more difficult to create mechanical joints because you are designing inside of the part environment. Only one advantage is that it has an automatic slice, so when you create a sketch, it will slice the cross section for you. But if you do that with the point cloud, you need to do a box crop to create a sketch. Okay, that's one advantage. It's more efficient if you are going to reverse a single part. So this, I will show you how I reverse this lure and model the split mold in a fast pace. Okay, thanks you guys for watching. I'll see you in the next video.